Now we want to look at piecewise functions. Okay. Now, when we talk about piecewise functions, it's still just a function. It's still just a graph or an equation, but it's broken into pieces, and each piece is defined for a certain amount of domain values. Okay. So for certain x's, maybe we use one piece, and for other inputs, we use a different piece. So when we're evaluating piecewise functions, what our strategy is going to be is to determine which piece to plug the value into by looking at the domain restrictions to the right of each piece. Sorry, my lead's dying. Of each piece. Okay, so we're going to determine which piece we're going to plug our value into by looking at the domain restrictions which are written to the right of each piece. So let me show you on this example. Here's our first piece. Our first piece says that when we plug an x into this, we're going to do -4 times that input and add 1. Now we're only going to use this piece when we're plugging in x's that are less than -4. Okay? Then this is our second piece. Our second piece says to do -3 times our input. But we're only going to use that piece if the x that we're plugging in is between -4 and 0. Okay, and then we use this third piece if our x is greater than or equal to 0. Okay, so these are our restrictions, and this is where we just determine the points that we're plugging in, which of these does it fit into, which of these does it satisfy, and whichever one it satisfies, number 1, 2, or 3, that's the piece that we plug into it, or that we plug it into, rather. Okay, so I'm going to number these. I'm just going to say this is piece number 1. This is piece number 2, and this is piece number 3. So when I look at my numbers here, I want to evaluate f of 1. So remember, whatever number is in here, this is my x. So if my x value is 1, I need to know which of these does it fit into. Does 1 satisfy option number 1, option number 2, or option number 3? So in order to determine that, I just look. Is 1 less than -4? No, it's not. Is 1 between -4 and 0? No, it's not. Is 1 bigger than 0? It is. So that means for this one, I'm going to be plugging it into option number 3. Right? Okay, then I want to do the same thing here. Or here, let's just go ahead and work it out. So f of 1, we determined because 1 is greater than or equal to 0, 1 needs to be plugged into this last option. So this last option says we're going to do our input squared and -2. So I'm going to do 1 squared and subtract 2. Okay, 1 squared, is just 1. -2 gives me a -1. Okay. Then I want to do the same thing with f of 6. To determine which one I need to plug f of 6 into, I look at the number 6. Is 6 smaller than -4? No. Is 6 between -4 and 0? No. Is 6 greater than or equal to 0? It is. Okay, so I'm going to plug 6 into number 3. Number 3 again says to do my input squared and then subtract 2. Okay, so I'm going to go ahead and plug in my input, which is 6, and square it, and then subtract 2. So 6 squared gives me 36, -2 is 34. Okay. Then I look at my next one, which is f of 0. Okay, I need to know which one am I plugging this one into. Is 0 less than -4? No. Is 0 between -4 and 0? Maybe. But notice on this one, this is strictly less than 0. Okay, there's no equal to bar here. So if it's not included here, then I can't include 0 in this piece. Okay, so then I look at the next piece. This says x is greater than or equal to 0. So because we're plugging in a 0, this one actually is going to go into number 3 as well. Gee, not a lot of variety here. So if I plug 0 into this third piece, I'm going to get 0 squared minus 2, which is just 0 minus 2, which is just -2. Okay. Let's see if our last one is something we're not going to plug into number 3. So we look at this last one. Okay, we're looking at -4, f of -4. And I want to know which one am I going to plug -4 into? Is -4 I lost my place. All right. So is -4 less than -4? Well, no, it's not. It's equal to -4, but this does not include the equal to bar. So I can't use that one. So then I look at this one. This one has a -4, and notice it has the equal to bar. So this is saying this is for x's that are greater than or equal to -4, but still less than 0. So this is the one I'm going to plug this one into. So this is number 2. So notice number 2 says to do -3 times my input. So I'm going to do -3 times my input, which is -4. -3 times -4 is +12. Okay, does that kind of make sense? All right, I want to look at a couple more just to give you a little bit more experience of seeing which ones, what pieces you have and how to determine based off of the restriction over here, which piece to evaluate at. Okay. So let's look at a couple more. Or actually, you know what? Let me have y'all try this one. Let's change this from an example to a practice problem. Okay, so let's let y'all practice this one. So for this problem, evaluate f of 10, f of -7, f of -10, and f of 0. Okay, determine if you need to plug it into a number 1 or number 2 piece. Okay, go ahead and pause the video and then play it whenever you're ready to check yourself. All right, so let's go ahead and look over these practice problems. The first one is f of 10. To determine which piece I need to plug it into, I'm looking at my stipulations here. Is 10 less than -7 or greater than or equal to -7? Well, it's greater than or equal to, so I'm going to plug it into the second piece. The second piece says to do 7 times my input minus 8. So I do 7 times my 10 minus 8, which simplifies to 62. Okay. Then I look at -7. -7 actually shows up on both of these, but only the second piece includes with the little equal to bar -7. So f of -7 is going to be plugged into the second piece. Second piece says to do 7 times my input minus 8. So I do 7 times my -7 input minus 8, which simplifies to -57. Okay. When I look at f of -10, -10 is smaller than -7, so it's going to get plugged into this first piece. The first piece says to do 2 times my input plus 4. So I do 2 times my input of -10 plus 4, which simplifies to -16. And then my last one is f of 0. 0 happens to be larger than -7, so I am going to plug it into the second piece, which says to do 7 times my input minus 8. So I'm going to do 7 times my input of 0 minus 8, which leaves me with just -8. Okay, so when we're evaluating piecewise functions, all we do is determine, based on the stipulation, which piece our value corresponds to, and then plug it in accordingly. Okay, when we graph piecewise functions, we're going to do it a lot of the same way. We're going to look at those domain restrictions and graph them one piece at a time. Okay, so here's our strategy for graphing. We're going to make an XY table for each piece. Okay. And I'm going to put here as a note, be sure to include endpoints in the table so you get an accurate graph. Okay, make an XY table for each piece. Now, if each piece has start and stop points, we have to make sure we include those very important endpoints so that our graph looks correct. Okay, so let me go ahead and just show you an example of what this looks like. So here's our first one. We're going to graph this function, and then we're going to also find the domain and range of the function once we have it graphed. Okay, so what I want to do is I want to make an XY table for each piece. So the first piece is x plus 1, and this is for x's that are less than -2. So I'm going to go ahead and just put this first piece over here. So I have x plus 1, and this is specifically for x's that are less than 2. So when I make my XY table, I want to pick x's that are specifically less than -2. Now, I want to make smaller numbers, but I know that this piece is going to stop at -2. Even though it doesn't have an equal to bar, it stops at -2. So I'm going to make sure I include -2 on my table. Okay. Now I'm going to put an open circle here so that I know when I graph it, I don't want to include that because it's not included on this piece, but I still need to mark where it would be so I can get infinitely close to -2. Okay, and then I want to pick numbers smaller than -2. So -3, -4, and notice there's no ending point. It just says any number smaller than -2, which means it's just going to keep going and going in that direction. Okay, so these two things are going to help me make my graph shape. So now all I have to do is plug these numbers into that piece. So when I plug in -2, -2 plus 1 is -1. -3, well, -3 plus 1 is -2. And when I plug in a -4, -4 plus 1 is a -3. So I now have enough points to graph that piece. So over here on my graph at -2, I go to -1, which is down here. And remember, that point is not included. So I want to make sure I use an open circle there. Okay. Then at -3, I'm down at -2. I can include that point. And at -4, I'm down at -3. Okay. So this was the side that started with the open circle, just like on my picture over here. But then down on this side, remember I drew an arrow because it's going to keep going, because it can go to any number less than -2. So I'm going to go ahead and just draw my arrow to show that that piece keeps going. Okay. All right. So there's my first piece. Now I want to do my second piece. So my second piece is -2x minus 3. Now this piece is only for x's that are greater than -2. So again, let me throw my pencil. So again, when I make my XY chart, I have a stopping point at -2, right? Because this is x's that are greater than -2. So I can't even start until I get to -2. But it does not have that equal to bar. So again, this one's not included, so I want to use an open circle at that point. Okay, and then I want to pick some other points that are greater than -2. So maybe -1, 0, okay, any other point that's bigger. It's going to keep going and going and going, right? Because there's no stopping point. All right, so now that I have my 3 points, I'm plugging them into this piece of my piecewise function to see what the outputs are. So when I plug in a -2 up in here for x, so -2 times -2 is +4, minus 3 is 1. When I plug in a -1, -2 times -1 is +2, minus 3 is -1, right? And then when I plug in 0, -2 times 0 is 0, minus 3 is -3. Okay, so now I have some points to graph this point. So for this piece, at -2, I'm up at +1. So I go to -2 on the x and up to +2 for the y, and I'm using an open circle there, okay, because it's not included, right, because we didn't have the equal to bar. Then I plot the point -1, -1, which is here. And then I plot my last point, which is 0, -3, okay? But remember, it keeps going and going and going from that point. So when I connect my dots, I want to draw an arrow going in that direction because it can be any x greater than -2, okay? So now that I have my picture, I want to use what we learned at the beginning of this lesson to list the domain and range. Okay, so now that we have it graphed, let's go ahead and find our domain. Remember, domain is left to right. So the furthest x value to the left that this graph is going to go looks like right here, right? But an arrow means that this is going to keep going and going and going and going and going. So this picture is going to keep going, which notice this picture spans across all these negative x values. So that's going to go all the way back to -infinity, right? And then as I travel back this direction, it spans all these negative x values, but this piece stops right here, which is at x equals -2. And notice this piece also does not include -2. So if there is a break where there is a point where there's not an x value defined, like here with -2, then that means there is a break in my domain. So I have to stop my domain at -2 and use a parenthesis to show -2 is not included. And then I can look at the second piece. The second piece starts at -2, but it also is not included. So I'm going to use a -2 with a parenthesis there. And it's going to go from -2, and then this picture is going to keep going and going and going and going, right? So it's going to span across all the positive values of x. Okay, so what that means is this picture is basically going to cover every x value from -infinity to +infinity, with the exception of -2, because -2 is not defined for this piece or this piece. So my domain is from -infinity to +infinity, but taking that -2 out. Okay, now let's look at our range. Our range is our lowest y value. So if I look at how low this picture is going to go, well, this picture is going to keep going lower and lower and lower and lower and lower, right? And this picture is going to keep going lower and lower and lower and lower. So when I'm thinking about my y values, if it keeps going lower and lower and lower, it's going to span all the way down through all the negative y values. So it's going to go all the way down to -infinity. And then as I venture further north, right, this picture, this one goes all the way up to this point, which is at y equals -1. Now it's not included here, but it is included here. So technically, my y values don't stop at 1, right? This piece stops at 1, but I still have y values that are included on the second piece. Okay, so there's no break in coverage. All my negative y values are covered all the way up to -1, and then it stops being covered on this piece, but it picks up and it's still covered on this piece. And y values are still being covered all the way up to here. This is where both pictures completely stop, and that's at y equals +1. And notice it's not included at +1 because we have an open circle. So it's going to be from -infinity to +1 with an open parenthesis. Okay. Whew. So XY table to get points for each piece, graph each piece, and then determine domain and range once you have the picture. Okay. All right. I'm going to do 2 more examples, and then I will let you guys try some. Okay. Or try one, I guess. All right. So here we go. First piece. First piece is 3. And this is for x less than -3. X is less than -3. So if I were to make an XY table, and I'm picking x values, this piece starts at -3, right? X is less than -3. -3 is an important endpoint. Now, -3 is not included with an equal to bar here, so I want to put an open circle so I know that it's not included, okay? Then I want to pick x's that are specifically less than -3. So maybe -4, -5. And I could keep going, -6, -7, -8, right? These are going to keep going. So I'm going to put an arrow here so that I know when I graph it that that side should keep going and going and going. Okay. Now, the cool thing about this is I don't have anything to plug it into, right? This piece says for all these x's that are less than -3, it just equals 3. So I just can go ahead and fill this in. This one's going to be 3, this one's going to be 3, this one's going to be 3, right? As far down as this goes, it's just going to be 3, 3, 3, 3, 3. So let's go ahead and graph and see what this piece looks like. So my first point is -3, 3. So I'm going to go out to -3 and then up to 3. And it's not included. That's going to be an open circle, right? Because we're not including -3 with a bar here. And then we have the point -4, which is up at 3, -5, which is up at 3, right? If we kept going, -6, -7, -8, they're all going to be up at 3. So this is going to keep going in this direction, okay? So that's what my first piece looks like. Now let's see what my second piece looks like. My second piece looks like the square root of x. And this is specifically for x's greater than 0. So x is greater than 0. So I'm going to make my xy table, okay? And I want to make sure to include these important endpoints on my domain here. So if x is greater than 0, I need 0 on there. There's no equal to bars, so I'm going to put an open circle to let me know I'm not including that when I plot that point over here, okay? And then other x's that are bigger than 0 would be like 1, 2, 3, 4, 5, 6, 7, 8, 9, right? But I know that these points I'm going to be plugging into a square root, so I'm going to try to pick points that I know are perfect squares. So 0 is a perfect square, 1 is a perfect square, 4 is a perfect square. Okay, that should give us enough. And it could be anything bigger than 0, so it's going to keep going and going and going. So I'm going to have an arrow that's going to keep going on that end. So let's go ahead and plug these in and see what they look like. The square root of 0 is 0. The square root of 1 is 1. And the square root of 4 is 2. Okay, so let's go ahead and plug these in. So I have the point 0, 0, which is an open circle at the origin, right? Because it's not included. And then at 1, I'm up at 1. And at 4, I'm up at 2. So this looks something like this. Okay, little half parabola type shape. Okay. All right, so now that I have it perfectly graphed, now I want to go ahead and identify my domain and my range. So remember, domain is my x values, which is left to right. So these are my x's. Oops, sorry. And these are my y's. So when I look at my domain, the furthest to the left that this picture is going to go is, notice, all these x values are going to be covered by this line. This line is going to keep going and going and going. So all these negative x's are going to have coverage on this piece. So we're going to start at -infinity. Now as I start traveling to the right, notice all these negative x's are covered by this piece, but this piece stops at x equals -3. Okay, so because this stops and the other piece hasn't picked up yet, I'm going to have to stop my domain at -3. Because that's an open circle, I'm not including -3, so I'm going to use a parenthesis. Okay, then my domain picks up again. I skip over -3, I skip over -2, -1, and this piece starts at x equals 0, right? But it's not included, so I'm going to use a parenthesis at 0 to show that 0 is not included. But notice this piece is now going to span across over all these positive x values, and it's just going to keep going and going and going. So it's going to go from 0 out to +infinity. Okay, so that's my domain. And now I need to find my range. So my range is all possible outputs or all possible y values. So the lowest y value on this picture is this point right here. And that point is at y equals 0. But it's an open circle, so we're not including 0. And then I want to see how high this goes. Okay, so notice this piece is going to keep going and going and going, right? It's not increasing very fast, but it is going to keep going up and up and up and up and up. So if it keeps going up and up and up and up and up, it's going to increase all the way up to y equals infinity, right? Now this piece, the only y value it has is 3. We don't have to stop our range at 3 because this one's going to go up to 3 and it's going to continue going past 3. It's going to just keep increasing up. So we're going to go ahead and just say from 0 to infinity. Okay. All right. Let's look at one more and then I'll have y'all try one. Okay. So on this one, we're going to do our 3 pieces separately. So first piece is negative x plus 1. And this is for x's strictly less than negative 2. So on my xy table, I want to pick negative 2 because that's an important endpoint, but it's not included. So I use an open circle. Then I pick additional x's that are less than negative 2. So I'm going to pick negative 3 and negative 4. So all 3 of these numbers, I'm going to plug into that piece. So when I plug in negative 2 into negative x, that makes it a positive 2, plus 1 is 3. When I plug in negative 3 into a negative x, that makes it a positive 3, plus 1 is 4. When I plug in a negative 4 into a negative x, that makes it a positive 4, plus 1 is 5. Now, there's no endpoint on this. This says that my x's can be anything less than negative 2. So this side's going to keep going. So let's go ahead and graph this piece of the function. So at negative 2, I'm up at positive 3, and it's not included. It's an open circle. Okay. At negative 3, I'm up at 4, and at negative 4, I'm up at 5. Okay. And remember, that side's going to keep going and going and going, right, with an arrow. So when I connect these dots, I want to make sure I keep drawing them, continuing on with an arrow. All right, so there's my first piece. Now let's look at our second piece here. Our second piece is x squared. And this is specifically for x's that are greater than or equal to negative 2, but less than 1. So negative 2 and 1. Okay, so these are my important endpoints that I need to make sure I have on my xy table. So I have negative 2, and then I'm going to pick some numbers in between, say negative 1, 0, and 1. Okay, you don't have to do all of them, but we have to make sure we include negative 2 and 1 for sure. Okay, now negative 2 has the equal to bar, so it's included. So I'm going to put a solid dot next to it. And then 1 is not included. It doesn't have the equal to bar on its inequality, so it's not included. So we're going to use an open circle. Okay, so let's go ahead and plug in these points and see what this shape looks like. So when I plug in negative 2 squared is positive 4. Negative 1 squared is positive 1. 0 squared is 0. And 1 squared is 1. Okay, notice I don't have arrows on either ends because this has a start and stop point. So when you graph it, you should have a start and stop point. Okay, so our first point is negative 2, 4. So at negative 2, I'm up at 4. And it's included. So I'm going to do a solid dot. At negative 1, I'm up at 1. 0, I'm at 0. And then positive 1, I'm up at 1, and it is with an open circle, right? Because that's not included. So when I connect these, notice it's making a little parabola, right? We had an x squared that should make a parabola shape. All right, so now we have 2 pieces. 2 pieces. Oh, I didn't do it right. What? Oh, because this is a negative. This is a negative. Oh my gosh. It's a negative x squared. So let's put our negative in there. I'm sorry. So when we square each of these numbers, this isn't going to change it too much. When I square each of these numbers, I'm still going to get 4, 1, 0, and 1, but then there's going to be a negative out front. So that's going to make this a negative 4, a negative 1, negative 0, still 0, and a 1 becomes a negative 1. Okay, so I just need to regraph it. I'm sorry. I'm sorry. I hope we're using pencil. Okay. Meh. All right, here we go. So let's regraph. So at negative 2, we're down at negative 4. That's down here, and it's included. At negative 1, I'm at negative 1. 0, I'm at 0. and 1, I'm at -1 with an open circle. Okay, there we go. That's a little bit better. Oops, almost missed my dot. Okay, there we go. All right, so we got our first piece. We got our second piece. I'm not going to make a mistake on the third piece. Are you ready? Here we go. All right, last piece. We have x minus 3. And this is specifically for x's that are greater than or equal to 1. So x is greater than or equal to 1. We're going to make our xy table, and our only point of reference is 1. So we need to make sure we put a 1 as our x value, and it's included because we have this equal to bar. So we can go ahead and include it with a solid dot, and then we're going to pick x's that are greater than 1. So I'm going to pick 2 and 3. Okay, so when I plug these 3 points in, when I plug 1 in, 1 minus 3 is -2. When I plug 2 in, 2 minus 3 is -1. And when I plug 3 in, 3 minus 3 is 0. And notice I could keep plugging in numbers, right? Because it's any number bigger than -1. So this end is going to keep going and going and going. So now that I have my numbers, let's go ahead and plot them. So when x is 1, I'm down at -2, and it is included. At 2, I'm down at -1, and at 3, I'm at 0. Okay, but from the 3, it's going to keep going and going and going. So this is going to keep going that direction. So when you connect your dots, make sure it's still going in that direction. All right. Whew. So we have our piecewise function. Let's go ahead and identify our domain and range. So domain is our x's, so left to right, and then our range is our y values, so south to north. Okay. So domain first. How far are we going to have coverage to the left, right? When we go in the x to the -infinity direction, notice this piece is going to keep going and going and going. So this piece is going to span all these x values, right? And it's going to keep going all the way back to -infinity. So our domain is from -infinity, and then I need to know how far it goes to the right. So this piece is going to have me covered all the way up to this point, right? That's where this piece ends. And that is at x equals -2. Now it's not included here, but notice at -2, it is included here. So I don't have a break in my coverage because even though this piece stopped, this piece picked up with a defined point right where the other one ended. So there's no break in coverage, so we're still going. So we're defined at -2, -1, 0, all the way over to this piece stops at 1, right? But right where this piece stops at x equals 1, this piece starts at x equals 1, and it's defined. So again, no gap in coverage. Okay, so this one picks up at 1, and then it's going to go across all these values. It's good for 2, it's good for 3, it's good for 4, it's good for 5, and this is going to keep going and going and going. So it's going to go all the way out to positive infinity. Okay, so even though we had 3 different little pieces, because when we look at them collectively from left to right, we have no x values that are not defined or not, having an issue, then our coverage covers everything from -infinity to infinity. So our domain is all real numbers. Okay, let's look at our range and see if the same thing is true. I want to know how far south is this picture going to go. So the lowest I can go here is this point right here. And there's no arrow saying it's going lower. It stops right there, right? And that y value for that piece is at -4. And because that piece is solid, I can include it with a bracket at -4. Okay? And then from -4, it's going to be covered up to -3, up to -2, up to -1, right, up to 0, okay? And then from 0, it looks like I have a break. But if you look over here, this one is defined at y equals 0, right? And it's going to keep going up and up and up and up and up, as is this one going to keep going up and up and up and up and up. So if I look at all these pieces together, from -4 all the way up to infinity, I have at least one or more pieces covering my y values. So it's going to go from -4 up to infinity. Okay? All right. So let's try it. Let's see how you guys do. So here is one for y'all to try, okay? And when you're ready, unpause the video. We'll see how you did. All right, so here we go. So when we do this first piece, this x squared, right? We are picking x's that are less than 0. So we need 0, but it's not included, so we use an open circle. And then we pick all numbers smaller than 0, right? Because x is less than 0. So -1, -2, -3. If you chose more, that's fine. But it's going to keep going and going and going with a arrow, right? So when we plot these points, we're going to get this little half parabola shape over here, right? So then we have our open circle on one end and our arrow on another. Now let's look at our second piece. When we look at this second piece, we have -2x plus 4. This is specifically for x's greater than 0. So again, we want to have 0 on there because it's a reference point, right? And is an endpoint, but it's not included with an equal to bar. So we're going to use an open circle, and then we're going to pick values that are greater than 0. So I just picked 1, 2, 3. If you kept going, that's fine. But notice it's going to keep going with an arrow because it's all values greater than 0. Okay, so when we graph this XY table, okay, it starts at 0, 4 with an open circle, and then it continues on down. So once we have it graphed, then we determine our domain and range. Notice this piece is going to keep going off to -infinity. This piece is going to keep going to positive infinity. So when I go left to right, the only point that I have on here where I do not have a defined x value is at 0, because this one doesn't include 0 and this one doesn't include 0. So that means I can go from -infinity up to 0. I have to take 0 out. And then from 0 to infinity, okay? Now my range, however, I don't have an issue at all, because this one's going to keep going all the way down to -infinity. This one's going to keep going all the way up to positive infinity, and we have every y value in between covered, right? Because where this piece stops, this one keeps going down. Where this piece stops, this one keeps going up. So our range is going to be all real numbers from -infinity to infinity. All right. Okay, so that is the end of domain and piecewise functions. I know it's a little bit longer. If you need to go back and review any part of this video, please do so. And you should now be able to complete your domain and piecewise functions assignment in Knewton, as well as the piecewise functions, graphing piecewise functions worksheet. Okay, so you have 2 assignments that go with this. If you have any questions, please let me know.